Hello 171 class, this is your notes for section 3.3, properties of logarithms. So we did some very basic properties of logs in 3.2, but these are some more in-depth and a little bit more complex properties than the ones that we studied before. The product rule, what you're going to see with these properties is we take the inputs of these logarithms and we change basically what's going on here. We got multiplication going on and we're ending up with addition. It's kind of like the order of operations, and we move things down. Now parentheses is top dog in the order of operations. We can't do anything with parentheses, but exponents, multiplication, division, these other operations, when we go inside a logarithm, we have an operation, multiplication. What a logarithm property does is it takes, what these properties do anyway, is it takes us down a step in the hierarchy. So multiplication inside the log, we can write that as addition of two different logarithms. Okay, division, we'll see that property next. We can write it as subtraction of two different logarithms. And then even exponents. Repeated multiplication, we can write that as multiplication. So everything kind of moves down a step, a ladder, a rung on the ladder of the order of operations. All right, now, the very first thing I'm going to do on all these slides when we come up with a new rule is show you where it comes from. And you're going to see it all is just based on the definition of logarithm and that transformation from logarithm to exponents, and then it's just properties of exponents. So I've got s equals the log base b of m and t equals the log base b of n. The first thing I'm going to do is just rewrite these in their exponential form. Alright, and now I have b to the s equals m and b to the t equals n. Alright, now I'm going to multiply m times n together. So m times n is equal to b to the s times b to the t. Okay, m is equal to b to the s, so m is b to the s times n equals b to the t. Okay, and then I'm going to that right hand side in a simpler form using a property of exponents. If you had the same base, b, to different powers, you just add the exponents. So b to the s plus t. Alright, now last thing I'm going to do, I'm going to come up here, I'm going to change this back to log form. Okay, so remember, this is the base, this is the exponent, so when I change it back to log form, this becomes the log base b. Right, there's the base. This is the exponent, so that's on the other side of the equals, so s plus t. Alright, and then that leaves this m times n to be the input. So log base b of m times n equals s plus t. Well, s is the log base b of m, t is the log base b of n. And so since s is the log base b of m and t is the log base b of n, I can replace those and I end up with a log base b of m times n equals log base b of m plus log base b of n, which is what we get here. So that's the product rule, and it works for any valid log base. As long as you have multiplication in here, you can change that to addition. We have now two logs, right? The log of the first value and the log of the second. Okay, so that's the product rule. Quotient rule, exact same concept, except now we've got division and we change that to subtraction. So the work that we did before, all of it is identical, except we're dividing at this step. M divided by n equals this divided by this, and then that same property, same base, different exponents with division, that becomes subtraction. So we're subtracting the exponents, and then when we switch it to log form, I just switch m divided by m to the fraction form. The log base b of m divided by n is s minus t now, and then s and t again are replacing them with what they were here. So the exact same work, is just division and subtraction because of that property of exponents. Alright, now let's use the product and quotient rules and show how we actually do this stuff. Now, the log base 4 of 7 times 5. According to the product rule, we can take each of those two numbers, the 7 and the 5, and give them their own logarithm, and it's still completely valid. Now, again, we're going to, in just a couple more minutes, have the way to put this into the calculator, but for now, just know that what I'm going to show you, even though I'm using log base 10, which is the common log, it works also for any log base. So I'm going to put in 7 times 5. Alright, the log of 7 times 5, ignoring the 4 for now, equals this. And if I type in the log of 7 plus the log of 5, I'm just showing you that it does work. So we get the exact same thing. Okay, so this log property works. Now, do not confuse it with this being a plus. If I had log of 7 plus 5, and then I typed in the log of 7 plus the log of 5, they're not the same. Okay, this product rule only works when the original input had multiplication. We can switch that to addition. We can't switch addition in the parentheses to addition of the logs. Alright, then we have here log of 10x. So according to the power rule, or product rule, I can change that to log of 10 plus the log of x. And when you do your homework here, you're going to be expected to, if you see something that is a whole number or a fraction or something that you can simplify, that you should know how to simplify, then you're going to be expected to simplify it. So the log of 10, what do I raise 10 to get 10? I raise it to the first power. This is actually just 1 plus the log of x. Alright. If you don't know, if you don't recognize that, it's not clicking yet, just type it into your calculator and see if it simplifies. And if you get a whole number out, then you were expected to know that logarithm is a whole number. Alright, now again, at the end of this section, we'll be able to do this for any log base on our calculator. These are not whole numbers. Log base 4 is 7, log base 4 is 5 are not whole numbers. You're not expected to make those into the decimals if they are. But anything that does result in a whole number or a fraction, you are expected to make that change. Quotient rule, it's the log of the top minus the log of the bottom. So this would be the log base 7 of the top, which is 19, minus the log base 7 of x, the bottom. Alright, and then for the second one, the natural log of the top, e to the third, minus the natural log of the bottom. And again, just like the log base 10, or the log base 10 of 10 was 1, log base e of e to the third is just the 3. And once again, you should know that, but if you're not comfortable enough with it yet, you can always type in these expressions. Second, ln is e to a power, so e to the third. So natural log of e to the third, hit enter, it says 3. As long as this gives you a whole number or a fraction, a decimal that doesn't repeat, a decimal that does repeat or terminates, you're expected to know that. You're expected to be able to come up with that. Alright, then the power rule. The power rule says if you have a log base b of something to a power, you can actually take that power and put it out in front of the logarithm and change that to multiplication. So it's like we were talking about before with the order of operations. An exponent is repeated multiplication, and then right below exponents in the order of operations is multiplication and division. And we can go one step of the ladder down. We can go from exponents to multiplication when logarithms are involved. So again, the proof of that, to show that it works, we do the same thing that we did before. S equals log base b of m. That means b to the s equals m. Alright, and now I'm going to take b to the s and m, and I'm going to raise both of them to the p power. Alright, so if b to the s and m are equal, then they're still equal when I raise them both to the p power. But what happens when you raise powers to powers? Remember, you multiply the powers. So this is s times p equals m to the p. And coming up here, if I rewrite this in log form, this is the base that we started off with. Okay, so that's the one I'm wanting to use. They both have bases now, but this is the one I want to use. So this is log base b. Alright, the exponent on the base is s times p, so I'm going to write that over here by itself, s times p. And then the input is what remains that we haven't used yet, so m to the p. Alright, and the last thing I'm going to do, twofold. One is replace s with log base b of m. And the other is just switch the order. S times p equals p times s. So I'm going to write this as the log base b of m to the p equals p times, and then s I'm replacing with the log base b of m. Alright, so there you see I end up just pulling that p down in front of the logarithm. You can take it off of the base and put it out in front and multiply. So another very useful property of logarithms that we'll use a lot when we're solving equations. Alright, let's practice using it. Use the power rule here. So a log base 5 is 7 to the 4th. I can bring that 4 down in front and write this as 4 times log base 5 of 7. Alright, for b, what I have to do here is, remember this is the natural log of, the square root is the same thing as the 1/2 power. So I rewrite it that way first, and then the 1/2 can come down. So 1/2 the natural log of x. Alright, and then for c, this 5 can come down out in front. So I end up with 5 times the log of 4x. Okay, now, this is just the power rule, but because there's multiplication in here, I could expand that as well. And watch what happens when I expand it. Remember with the power rule, ignore the 5 for a second. This expands to the log of 4 plus log of x. Okay, we've got a log with multiplication on the inside. You can rewrite that as addition and give each one of these its own logarithm. But because I expanded this after the power rule, I really need a parentheses there or some grouping symbol to indicate that all of this that's been expanded is being multiplied by this 5. And then technically we would have to distribute that 5 through. So 5 times the log of 4 plus 5 times the log of x. Right, both of these are being raised to the 5th power. So when we expand logarithms, the power rule, we have to keep this in mind, that if we use that power rule, when we expand these things completely, if this has multiplication on what's being raised to a power, then we'll end up having to distribute that power through at the very end. Alright, so product rule, quotient rule, power rule, we go in that order typically when we expand. We don't always have to, but that is the typical way to expand to make sure you get it correct. Okay, make sure you don't do these things. This is what we talked about before. If there was a plus sign in there, it's not the log of the first thing plus the second. It's not the distributive property. Alright, a lot of people think of this as multiplication. They still are not comfortable with function notation and think that we're multiplying here and that distributes through. That's not the case. Alright, so notice that none of these situations where it looks like the distributive properties taking place are true for logarithms. These are functions and these are the inputs of the functions. So it's not multiplication going on here. Alright, these are the big errors that people make when we're expanding or condensing logs. Alright, and notice this one right here as well. M times n to the p power. Only n's being raised to the p power. And we pulled the p out in front. That doesn't work. Okay. Here, both things are being raised to the fifth power, and it does work. Alright, but if only one of the two is being raised to that power, that's not a true statement anymore. Alright, let's expand these expressions as much as possible. So, x squared times the square root of y in logarithm. That's multiplication, so we have the product rule and we have exponents, so we'll have the power rule as well. So this is going to be, first of all, the log base b of the first thing, x squared, plus the log base b of the second thing, the square root of y, which I'm going to write as y to the 1/2. Okay, so there's the product rule. And then after we do the product rule, we'll do the power rule, meaning we'll bring these powers down in front. So 2 times the log base b of x plus 1/2 times the log base b of y. Alright, that's expanded. We did have a single logarithm with everything kind of crammed in here. Now we've expanded into 2 logarithms, and the powers are being pulled down in front as well. Alright, b. So the way we typically go here when we expand logarithm, to get your signs right, quotient, product, power is the way we typically go. So here we've got quotient, we've got product in the denominator, and we've got power because of the roots and exponents. So we're going to start with the quotient rule, meaning we're going to change this to subtraction. Log of the top minus log of the bottom. So log base 6 of x to the 1/3. Remember, cube root is the same thing as 1/3 power. Minus, that's the division bar, minus log base 6 of the denominator, 36 y to the 4th. And there's our multiplication that we're going to use for the product rule. Okay, now, when we go to product rule, we've already done this. I'm not going to pull the 1/3 down yet. I'm going to do that in the next step. But we're subtracting this, and since we're expanding this now with the product rule, again, we're going to need to expand it into parentheses. This is going to be the log base 6 of 36 plus the log base 6 of y to the 4th. Which is, if we distribute that minus sign through now, we end up with the log base 6 of x to the 1/3 minus the log base 6 of 36 minus the log base 6 of y to the 4th. So we distributed that negative sign through both of these terms in the parentheses. Alright, now product rule, I'm going to bring the 1/3 down. 1/3 log base 6 of x. The log base 6 of 36, again, this is one that you need to know. Alright, what do I raise 6 to get 36? I square 6. 6 squared is 36. So this is actually just 2. And then I'm going to bring the 4 down. So minus 4 log base 6 of y. Okay, now you may be looking at that thinking, oh, this is going to be terrible. I'm never going to be able to get this down. There is a simpler way to do it than to have to go through this every time. All you have to do is look at the numerator and denominator, and that's going to be your signs in the expanded form. Okay, x to the 1/3 power is in the numerator, and that's positive down here. The 36 was in the denominator, that's negative. The y to the 4th was in the denominator, that's negative. So positive, negative, negative, numerator, denominator, denominator. Okay, you just have to remember to do the power rule after this step. So literally you can go from here to here. You just have to understand numerator positive, denominator negative. And then you can kind of bypass this. You still have to do the power rule at the end and simplify anything that simplifies. But you can at least get your signs right without having to distribute the negative through. And a lot of people leave this last one positive by accident. Just remember, denominator negative, numerator positive. Right now, the opposite of expanding a logarithm is condensing a logarithm. And when we condense logarithms, we go from multiple logarithms to as few logarithms as possible. Ideally, just one for the equations that we're going to be solving later. But when we condense a logarithm, we're using these product, quotient, and power rules in reverse. Now, notice for the purposes of the product rule and the quotient rule, it's always 1 in front of the logarithms. So we always start with the power rule and kind of work our way back. It's basically the opposite of this. We go backwards, power, product, quotient, when we condense. Alright, so we already have ones here, so no need to do a power rule. We're going to do the product rule and multiply these two things together. So this is like my m, this is like my n. So I end up with the log base 4 of 2 times 32, which is the log base 4 of 64. And the log base 4 of 64, what do I raise 4 to get 64? I raise 4 to the third power. Okay, so that means this is all just 3. Alright, and then this has subtraction. Alright, so this is my m, this is my n, and I'm going to write this as a single logarithm. The log of, this is my numerator, 4x minus 3 divided by, this is my denominator, x. And you can't cancel this because of that subtraction, but there's my condensed form of that logarithm.